And the last one, exercise 5.3, we're asked to draw a Venn diagram that represents where finite languages, regular, weakly deterministic, and context-free, and any language all sort of fit together. So any language will be like this great big outside box. This will be any possible language that we're allowed. And then almost all of these are simple because they're just strict inclusions inside each other. So we have finite languages, and we know that all finite languages are regular because I could just construct a DFA to check every case. And I know that all regular languages are DCFLs because a DFA is like a special case of a DPDA that just never interacts with the stack. And then deterministic context-free languages are just a stronger definition than context-free languages, right? So that means this must be contained in that, which is itself a subclass of the class of, any language, right? The tricky case comes in when we talk about weakly deterministic. Due to the fact that languages that don't satisfy the prefix free property aren't weakly deterministic, that means this guy here will not be a superset of any of these three classes here. We know it has to be contained inside DCFL, but there'll be parts of finite and regular that poke outside it. So now we just have to find examples that fit in each section. So a finite language that isn't weakly deterministic, well, that's any finite language that doesn't satisfy the prefix free property. So the language of 0 and 00 fits the bill just fine. A language that's finite and weakly deterministic is any finite language that does satisfy the prefix property. So a 0 by itself will do. A regular language that isn't weakly deterministic is any regular language that isn't prefix free, 0 star. And then we want something that's regular and prefix free. So if I just put a special symbol on the end, like a $, then this will stop being prefix free, right? Because the $, sort of tells me where the string ends. I know I won't have to read any more zeros afterwards. Okay? Something that's weakly deterministic and deterministically context, well, this is a strict superset of that. So we need to find something that lives here that isn't regular. Okay, a classic non-regular language is 0 to the n, 1 to the n. And this will be weakly deterministic because no string of this form will be a prefix of any other string of this form. The exception being if we allow n to be 0 because epsilon is a prefix of any string. So we have to add the constraint n is greater than 1. If I want something that's deterministically context-free, I can just drop this constraint. So the same language again, but here n is allowed to be 0. And then something that isn't deterministic, so we talked about that before, W reverse, where W is a string. And then something that isn't even context-free, take any example from exercise 1. So 0 to the n, 1 to the n, 2 to the n, where n is any number. Okay, now that's every region filled.